Every civil engineering student opens this software and freezes. The interface is scary, the units are wrong, and nobody teaches how to even start. But in this video, I'm going to show you step by step how to go from beginner to launching your first real project, just like a working engine. Hello and welcome. My name is Dianga Bertrand. I am a practicing civil engineer and a master's holder in civil engineering. I have helped students and interns who were totally confused and now the design confidentially and professional, just as you'll be by the end of this series. By the end of this short video, you will know how to set correct units like in millimeters, in meters, and in kilonewton. Understand robot interface, what to touch and what to avoid. Create your first real project layout ready for modeling. Okay, let's begin. First, when you open Autodesk Robot, you see your recent projects. Like mine, I love my audience. Then on your left, you have new project. So we are going to use the building design model. We are going to choose the building design. Now, some other versions of Autodesk Robot opens directly to this interface. For that case, you use File, come to New Project, and choose your building model design. Now, before you do anything else, set your units. To Tools, navigate down to Job Preference. Click on Units and Formats. Now you have the metric system and the imperial system. For those using feet and inches, you can work with the imperial. For those using meters, millimeters, and kilonewton, you can work with the metric. Click on the plus button attached to units and formats and navigate down to dimension. As you can see, our structural dimensions are set to meters, section dimensions to centimeters, section properties to centimeters, steel connections to millimeters, diameter of RC bars to millimeters, so that we can have rod 10, 12, 16, 14, 20. Reinforcement areas are set to centimeters square. Crack width of concrete elements are set to millimeters. Navigate down to forces. For force, we are going to have kilonewton. For moments, we are going to have kilonewton meter. And for the stress, we are going to have meganewton per meter square. Click on materials. For materials in this project, we are going to use Euro code. You can choose depending on the country in which you are found. For example, if you're found in France, you can choose Francais. In Canada, you can choose Canadian, so that your materials match the local materials in your area. For concrete, we are going to use concrete of 2530. Navigate down to design codes. We are going to use Euro code 2 for this project, so navigate down to EN 1992, revised 2014. And if your code isn't found in this region, you can click on More and choose from the list of codes here. We have the American Standard Code, we have the BS code. Click OK and make sure we are set to Euro code 1992, revised 2014. For geotechnical analysis, we are going to use GTU 1312. You can use the Euro code 7, revised 2013. Or if your code is not found within this area, you can click on More and check on your code here. Click OK. Then make sure our geotechnical, which is our foundation, is set to GTU 1312. All done. Click OK. This simple step saves you hours of confusion later. Trust me, this is where most engineering students mess up. Let me quickly show you the interface. It's super simple. On the left side is your project tree. It's where you trap all your elements in your stories. Like on story 1, you're going to trap the beams, pillars, and footings here. The top bar has all your commands. From the editing command to the view command to the geometry to your loads application, your load type, your dead load, live load, your analysis, your results, which are your diagram for bending moment, shear forces, your design, and equally your tools. On the right side of your screen, you have your axis definition. Then you have your structural elements such as your beams, your columns, your floors, your walls, your openings, core walls, and your member section, which is important in defining your column section, your beam sections. And finally, the center, which is your model space. Think of it like your drafting table. You don't need to memorize everything. Just know where to click. Now, let's create a simple grid commonly called axis line. Every structure starts with a base. Navigate to axis definition on the right side of your screen. Click. Now, you will see your x-axis, your y-axis, and your z-axis. Your x-axis follows the direction of your coordinate here. And your y-axis follows the direction of the coordinate here. Here's your y-axis. Your z-axis defines the story height. So, navigate to x-axis. To work efficiently in your x-axis, you need to choose your numbering system. So, the numbering system we'll use for the x-axis will start with 1, 2, 3. And for the y-axis, we are going to change the numbering system to ABC. Navigate back to x-axis. At position 0, 0, we want to add our first coordinate, which we call 1. Now, we want to have 3 numbering on the x-axis. 1, 2, and 3. With distance of 5 meters, type in 5 meters here. And number of repeats, we are going to put it to 2, since we already have 1. Then, we are going to navigate to Y. And at 0, 0, we will input our first axis, A. We just need 2 numberings on Y axis. So, we are going to type in a distance of 6 meters, number of repeat, 1. And we are going to click on Add. Once done, click on Apply. You have got your workspace ready for columns, beams, and slab. Before you forget, save your project. Navigate to File, click on Save, and type in the name of your project. I love my audience. Please subscribe to my channel and learn more daily. Once done, click Save. Make sure you keep your units consistent. You can now see the use of the numbers in the model space. Between axis 1 and 2, we have 0 to 5 meters, which is a distance. Between axis A and B, we have 0 to 6 meters, which is 6 meters. Look at what you just built. A real engineering workspace with correct units, a project tree, and a structural grid. In the next episode, we will model the actual structural elements, columns, beams, and slab, and apply materials just like in real-life projects. If you skip that, you'll be stuck at the launch pad. So hit subscribe now and let's keep building together.